Question number 7. This question is the last question of this paper. In this question, there are two concepts: geometric distribution and binomial distribution. A children's wildlife magazine is published every Monday. For the next 12 weeks, it will include a a model animal as a free gift. There are 5 different models: tiger, leopard, rhinoceros, elephant, and buffalo, each with the same probability of being included in the magazine. Sahim buys one copy of the magazine every Monday. Part A of this question is: find the probability that the first time that the free gift is an elephant is before the sixth Monday. This question is of geometric distribution. Because a fixed number of trials are not given, we have to find the probability until the success is obtained. Find the probability that first time that the free gift is an elephant is before the sixth Monday. There are 5 different models. Animals are tiger, leopard, rhinoceros, elephant, and buffalo. And each with the same probability. First part of geometric distribution. Animals are, first we write animals. T for tiger, leopard, L, rhinoceros R, elephant E, buffalo B. These are 5 animals with the same probability of being included in the magazine. So, geometric distribution, probability of uh, success is 1 over 5, then Q will be 4 over 5. We have to find the probability that the first time that the free gift is an elephant is before sixth Monday. We have to find the probability before the sixth Monday means we have to find the probability of x is less than 6. According to the adjustment of this inequality sign in geometric distribution, probability of x is less than 6 will be 1 minus q power 5. 1 minus q power 5. Q is given 4 over 5. So 1 minus 4 over 5 power 5. After simplifying, we get 0.672. Correct to three significant figure. This is the answer. Next part B of this question. Find the probability that Sahim will get more than two leopards, more than two leopards in the 12 magazines. Now this part of the question is of binomial distribution because fixed number of trials are given more than two in the 12 magazine. Fixed number of trials are given. So this question is of binomial distribution. The animal is here in this part of the question. That is leopard. Probability is same because all the animals have the same probability. So probability of leopard is 1 over 5 and number of magazines n is equal to 12. P is equal to 1 over 5 and Q will be 4 over 5. Now we have to find the probability Sahim will get more than two leopards. More than two leopards mean we have to find the probability of X is greater than 2. This means that 12C 3 12C plus 12C4 plus and so on 12C12. This is a lengthy calculation, so we will use its alternative 1 minus missing probability of missing values. Missing values are 0, 1, 2. Now we will use the formula for probability in binomial distribution. Formula is this. This is formula. Probability of X is equal to R. Formula for probability in binomial distribution. NCR Q power n minus R P power R. This formula we will use here. So 1 minus we are writing here 1 minus probability of 0, 1, 2. So 1 minus 12C0 because first value of X is 0. So N is 12 in this formula and C R is 0. So N 12C0 12C0 Q power Q is 4 over 5. We can write in decimal places 0. Uh, in decimal 0.8 power 12 0.2 power 0. Next is now we will take this value of X 12C1 Q power 12 minus 1 that is 11.2 power 1. Next is 12C2 0.8 per 10, 0.2 per 2. Now we will simplify these terms using a calculator. We get 1 minus the answer of the first option, first term is 0.06872. After calculation, this term, second term will be 0.20165, and after calculation, the third term will be 0.28347. Finally, we calculate, finally, we get the answer is 0.442, correct to three significant figures. The next part C of this question is find the probability that after 5 weeks, after 5 weeks, Sahim has exactly one of each animal. Exactly one of each animal. First, we write the animals. Animals are tiger, leopard, rhinoceros, elephant, buffalo. Find the probability that after 5 weeks, Sahim has exactly one of each animal. So, probability of each animal is same. So, probability of tiger is 1 over 5. Probability of leopard 1 over 5. Probability of rhinoceros 1 over 5. Probability of elephant 1 over 5. Probability of buffalo 1 over 5. Now, five different animals, since these are five different animals, we can arrange these five animals in 5 factorial ways. We can arrange in 5 factorial ways, so we will multiply here with 5 factorial because these five different animals can be arranged in 5 factorial ways. So finally, the answer will be, simplifying it, these are 5, 1 over 5 or 5 in 5 times. So we can write it in power form. 1 over 5 is 0.2, power is 5, 1, 2, 3, 4, 5 multiplied by this 5 factorial. Answer will be 24 over 625 in decimal places, correct to three significant figures 0.0384. This is the answer. In this question, 5 factorial is the number of ways in which we can arrange these five different animals. Like this is the first arrangement. Second arrangement can be T, R, L, E, B. and so on. It can be of this arrangement B, E, R, L, T. So there are, because these are five different animals, so we can arrange these five animals in five factorial ways. So we have multiplied by 5 factorial ways. The probability of each animal is 1 over 5. So this is the final answer. This comes to an end.